Now students, let us see the reverse engineering. So what is reverse engineering? So reverse engineering is the process of extracting the knowledge or design information from anything man-made and reproducing it or reproducing anything based on the extracted information. So this is a process that is we are having already something that is man-made. Okay, some system, some process, some parts, some component already we are having. So we are gathering all the uh, necessary information from that part. Okay, or design information, and based on that information we are reproducing. Okay, that is a reverse engineering. The process often involves disassembling something and analyzing its components and working details. So you know very well, in reverse engineering what we are doing, we are disassembling the part, then we collect all the information, we analyze that part, and we collect the working details of that. So more and more models are being built from data generated using reverse engineering, that is RE, reverse engineering, three-dimensional imaging equipment and softwares. So by using this we can generate or bring more number of models. So in this process, the RE is the process of capturing the geometric data from the another object. So what is basically RE as far as in this chapter is concerned? The RE is the process of capturing the geometric data from another object, and this data is available in what is termed as this point cloud. So where this data is available? So in uh, point cloud form, meaning an unconnected set of points representing the object surface. So these are the unconnected set of points representing the object surface. It is nothing but the point cloud form. So these points are need to connect by using the this RE software like GeoMagick. So we are having this number of points in the point clouds, and we have to connect that or connect those points by using the software like GeoMagick. So in many cases the data will entirely complete, that is sample may be holding in the fixture so that the surface adjacent to the fixture may not scanned, or some internal features. So the representation not turn out exactly how the object in the reality. Okay, so that's why we use these softwares. So engineering objects would normally scan using the laser scanning. Object having the complex internal features or anatomical models, so make use of this CT, that is computer tomography. So where this computer tomography is used, where the object having the complex internal features or the anatomical models. So in that case we can go for this software computer uh, tomography. So this technique work in similar fashion that AM, by scanning the layer by layer and using the software to join these layer and identify the solution boundaries. So like the additive manufacturing approach, this computer tomography methodology, rather I can say, which can be also use this layer by layer approach. Okay, so here they are scanning layer by layer and using the software to join these layers, and we can identify the solution boundaries. So in simple fashion, and this is the flowchart for the reverse engineering, you can say. First of all, see the forward engineering, that is our regular engineering. We are having the requirements, then we architect it uh, we make a design first, then this design undergoing testing, and after that we are implementing it. Yes or no? Or make the part. So here we are disassembling the product, get the required design information, that is design recovery, understood the design, and from that we can go for the requirement recovery to the requirements. So this is reverse engineering. Next thing, the computer aided engineering. Okay, so here CAE is computer aided engineering. So here 3D CAD is extremely valuable resource for product design and development. So for this CAE, this three-dimensional computer aided design is extremely valuable resource for the product design and development. The major benefit is that we can easily and cheaply make the design changes. The design changes are very cheap. The more we know about the product before it is built, the more effective that product is going to build. Definitely. So more and more information we are having about the product before it is going to make. So during the making of the product, then it is very easy, or it is not very difficult. It is smooth. It becomes smooth to make it when you know each and everything about the product. So if the problems are identified after physically makeup of part, this can be very costly, isn't it? So once we made all these design process, then according to that we define the manufacturing processes, set of operations sequences, we made the fixtures, holding devices, and we start the production. And after starting of the production, some problems are now getting rectified during the making of it. Okay, so when the physical makeup is done, all the setups are okay, and then we are identifying some problems, then it is very costly thing. Yes or no? So here 3D CAD can make use of AM to help the visualization and perform basic tests on candidate design prior to full scale commitment to the manufacturing. That is thing here. So this is the actual advantages of this. In 3D CAD we can make use of this additive manufacturing to help, or we can visualize the performance, or the some we can perform some basic test on that part. Okay, before it is going to the full-fledged manufacturing. The 3D CAD also link to other software packages, often using technique this FEM, that is finite elemental methods. Okay, and there is also the analysis. Okay, so the FEM to calculate mechanical properties of design, collectively known as computer aided engineering software. So there is this 3D CAD, we can connect or we can link the software to the finite element method, where we can able to calculate various mechanical properties of the design, and this collectively known as the computer aided engineering. Means the CAD system along with this FEM is nothing but our computer aided engineering softwares. So here the force, the dynamics, stresses, flows, certain properties can be calculated, how well the design will perform under certain conditions. So in this software, what we can do here, we can calculate the forces, the dynamics of that part, the stresses involved, the flow, or certain properties can be calculated to determine how well the design will perform. Such a software cannot easily predict the exact behavior of the part. So we are having all these things, but certain things that cannot be easily predicted by the software. So the analysis for these critical parts, the combination of this computer-aided engineering backed up with this additive manufacturing. So based on the experiments and its analysis to give the useful solution. Understood? So by knowing only these things, by using such a softwares, we cannot easily predict the behavior of the part. Okay. So the for the analysis of this critical part, the combination of this computer aided engineering, we backed up with the additive manufacturing, and based on some experimental analysis, may be useful solution for those critical parts. Okay. So next thing, we have to see the haptic based CAD, that is haptic based computer aided designing. So in 3D CAD system only working good for the engineering products that we are familiar with, but not suitable for the unusual designs, the designing these sculptures or the artistic design. Okay, so many consumer products are developed from the artist and the designers rather than the engineers. So it is not necessary that every product get manufactured by the engineer. So many products, consumer products rather I can say, these are designed from the designers and the artists. So for those peoples, our regular designing, it's quite the limitations or boundaries for their thinking, right? So AM is popular tool for artists and sculptors who are taking advantage of geometry's free form. So please, very important word is geometry's free form to create visually existing sculptures. So this is possible with this haptic based design, the haptic based computer aided design. So see here the free form modeling. The person is making the free model from this free form modeling system. So this is regarding to the haptic based design, computer aided design. So haptic based CAD modeling system like experimental system as shown in the picture work in a similar way to commercially available free form modeling system. This is a free form modeling system to provide the design environment that is more intuitive than the standard CAD system. Okay, so this is the basically the advantage of haptic based CAD, that is free from modeling. Also by the Phantom, which is haptic feedback device to provide force feedback relating to virtual modeling environment. The object can be seen on screen but also felt in 3D space using the Phantom. So these are the softwares. So while making the drawing itself or making the design itself, we can feel the three-dimensional uh, space. Okay, like the virtual designing. Okay, so this is the haptic based CAD modeling. Okay, thank you.